Hi and welcome to my YouTube channel. If you're new here, please subscribe, like and leave a comment if you find the video useful. In today's video, I'm going to show you how to use a water level sensor with an STM32 microcontroller. My name is Ali and you're watching CircuitGator HQ. Open up STM32CUBEIDE and click on create a new STM32 project. Then go to board selector and then type in the part number of the microcontroller that you're using. Click on the microcontroller and then click on next. And for the project name, you can just say WS for water sensor and then click on finish. Go to pinout and then click on clear all pinout. Then go to system core and the system, click on debug and then click on the serial wire. Then go to RCC and then under the high speed clock, click on the crystal ceramic resonator. We're going to be using ADC to capture the analog signals from the sensor. So go to analog, click on ADC and then click on channel in 0. And then when it comes to the parameter settings for the ADC, you can just go here where it says continuous conversion mode and then click on enabled. And then we're just going to leave everything as it is. If you'd like a more detailed video about ADC, there's a video that I have on my channel. You can just check it out. And then also I have another video where I show you how to do multi-channel ADC via DMA. The video is also on my channel. I will leave a link to those two videos in the description below. When we're done reading the ADC values from the sensor, we need to transmit them via UART to a serial terminal app so that we can see the output of the sensor. So go to connectivity, under UART 2, go to mode and then select asynchronous. Then for UART, we're not going to change anything. We're just going to leave everything as it is. Just take note of the baud rate. Also, if you don't know what UART or serial communication is and you'd like a detailed video, I have another video where I show how to transmit and receive data between your PC and your microcontroller. The link for that video will also be in the description below. When you're done setting up everything, click on Ctrl and S to save and then click yes to generate the new code and yes to switch to the new perspective. In the main C file, go to where it says private includes, and then here in the user code begin includes, we're just going to say hashtag include, and then we're going to add the string.h header file. Then we're going to just copy this, paste it here, and I'm going to add the stdio header file. Then we're going to scroll down to where it says private variables, and then here under user code begin PV, we're going to initialize two variables. One is going to store the values that we read from our sensor, and one is going to store the message that we're going to transmit via UART so that we can see the values that we're reading. So the first one is going to be uint32_t, and then you can just call it read value. And then the second one is going to be a character, so I'm going to say character and then say MSG, and then I'm going to give it a size of 50 bytes. Then you can scroll down to where it says user code begin 3 in the main while loop, and then here the first thing that we're going to do is that we're going to start our ADC by saying HAL_ADC_start, and then we're going to click on this one so that we can start our ADC peripheral. And then what we're going to do now to get our ADC values, we're not going to use interrupt or direct memory access. Instead, we're going to use the polling method. So I'm going to say HAL_ADC_poll, and then I'm going to click on this one that says poll for conversion, click on ADC1. Then for the timeout, I'm going to say HAL_maximum delay. After starting our ADC, we need to read the values and store them inside of our variable. So I'm going to say read value is equals to HAL_ADC get, and then click on this one that says get value and then click on the ADC peripheral. At this point in the code, our ADC value has been captured and stored inside of the read value variable that we created. So now we need to prepare this value and send it out to the serial terminal app via serial communication. So to do that, I'm just going to say sn printf, and then I'm going to say the message variable that we created. Then I'm going to say size of the same variable. Then I'm going to add a few characters. So I'm going to say water level, and then I'm going to say percentage symbol LU. Then I'm going to say /r and /n so that we can start printing from a new line. Then I'm going to add a comma and then take our variable and then put it here. And then below this, I'm going to say HAL_UART_transmit. Then I'm going to click on the first option and then click on my UART peripheral. Then for the data, we're going to be transmitting the data stored inside of our MSG variable, but we need to pass this variable. So I'm going to say uint 8 underscore t, then I'm going to point to the address of this variable. And then for the size, I'm going to say size of our MSG variable. Then for the timeout, it's going to be HAL underscore maximum delay. And then to avoid overloading our serial terminal app, I'm just going to add a small 100 milliseconds delay here. So I'm just going to say 100. And then we can click on the build icon to see that our code compiles without any errors. And then when it says finish building with 0 errors and 0 warnings, just click on the green play button, go to the debugger, and then here make sure that ST-Link has been selected, and then you can just click on scan, then click on run to upload the code. When the code has been uploaded, you can go ahead and open your serial terminal app. I'm going to be using Party for this video. What I need to identify here is the COM port connected to my microcontroller and the speed. The speed here must match the baud rate of your UART peripheral. So I'm going to go to the device manager, and inside device manager expand where it says port, and I see that my ST microcontroller has been connected to COM port 10. So I'm going to come here and then change this to 10. Then I'm going to click on open. So right now we see that the sensor is currently not reading any values. So I'm just gonna go ahead and put it in the water that I have next to me here. And then we see that when I put just the tip of the sensor, I get a range that is close to 2000, even though it's only just measuring a small section of the sensor. And then the more I put it inside of the water, the more the values increase until they get to the maximum ADC value, which is 4095. We can modify our code a little bit so that it's a bit more functional instead of just outputting values that have no meaning. So I'm just going to take this print statement and I'm going to remove it, and then below here I'm going to add an if statement. So I'm going to say if the value that we read is less than 3700, I'm going to take that statement that we removed, paste it here, and then instead of printing out this value, I'm going to print out low to indicate that the water level is currently low. Then I'm going to say else if the value is greater than 3700 but less than 4000, then I'm going to copy this line of code, paste it here, and then we're going to print media. And then we're going to do the same thing again, say else if this value now, put it here, and then if it's now greater than 4000, we're going to take this message again for one last time, put it here, then we're going to say hi to indicate that we're about to reach the maximum water level. Then I'm going to build the project again to say that we didn't introduce any new errors. And then we see that we don't have any errors, but we do have a couple of warnings. The warnings don't really matter much, but we're just going to remove them. So the warnings that we have is that we're not sending out any values, we're just printing out messages, so we don't need this part of the code here. So after you remove that, just build the project one last time, and then after it says finish building with 0 errors and 0 warnings, you can re-upload the new code to your microcontroller. We can see that the sensor is currently reading the water level as low, and then when I put it inside of the water, the more I put it inside the water, the more the message that is outputted changes. So you can see the more I put inside the water, the output changes from low to medium, and then eventually it goes to high. And then when I take it out, it goes back to medium, then it goes back to low. Thank you so much for making it to the end of the video. If you have any questions or any feedback, let me know in the comment section below, and I will see you in the next upload.